Now you recall that potential energy is called stored energy. We store it for later, and then later that stored energy can be used to make something move. Basically, stored energy, which is called potential energy, is converted to kinetic energy when an object moves. Now, most of the time on the MCAS, we'll be dealing with something called GPE, gravitational potential energy. It's caused by moving an object above a zero level on the ground. If this car is driving along on a flat area, and we'll call that the zero level down here, and he climbs a small hill. Now, he's not moving, so he has no kinetic energy, but he does have some height, doesn't he? Because he has that height, he could roll back down or fall, so he has that potential energy. We've stored it. It's a simple formula. It's mgh. Plug these things in here, and you get 36,000 joules of potential energy with this car sitting up here on that little hill. Same here with this cart. He's got a height of 20, doesn't he? He's not moving at all, but he does have potential energy again using mgh, 20,000 joules in that situation. And here I don't have a calculation or a number, but that ball is 5 meters above the ground, isn't it? Sure, that position above the ground gives it potential energy. In fact, it gives it gravitational potential energy. But there are other kinds of potential energy you could find on the test. Any situation where you can store some energy, you've got potential energy. So here's a situation. The spring here, if it's just at rest, is right here along that line. Then you could take a block and push on it, and you could compress that spring, couldn't you? If you let it go, it would push back out, wouldn't it? You have stored energy there. So the spring at rest has no potential energy. Compressed has some larger than zero. And of course, if you pulled it back also, you'd also be stretching it. If you let it go, it would move as well, wouldn't it? Yes. So the stretch, I should say spring here, sorry, um, also has potential energy larger than zero. Other examples? Oh, winding a clock. You folks may have never seen a wind clock. They're all electric now, but you can wind this, and it twists something inside there, the twisting. And then when you let go, it'll untwist and cause these arms to move, right? So you're storing potential energy here by twisting something. Write your code down. You need it later. EY723. Okay. How about a hockey slap shot? Sure, when you go back like that, you're storing a lot of energy, aren't you? The person's twisting his upper body, twisting his legs. His legs are probably coiling some. He's definitely storing potential energy there, and they can use that later for a slap shot. Here on a golf swing, the same thing. Bringing it back, twisting your body, bending your knees some. You're storing energy there too. Potential energy, but not gravitational potential energy, correct? And I've already mentioned that if you stretch that spring, let it go, it'll move the block forward, converting to potential to kinetic energy. If you let go here over time, this uncoils and moves the hands, right? Again, potential converted to kinetic. Obviously here when you come through in a slap shot, you've converted all that potential energy to forward motion. Same here in a golf swing. Storing it, but not by lifting the object above the ground via GPE, just storing potential energy. So here's the way it works. Whenever you run a test and the question is involving an object over the ground, like for instance discussing a plane over the ground, you're going to be talking about gravitational potential energy, MGH. Whereas if the problem talks about a golf swing or a stretching a spring or a rubber band, you're definitely, or a bow like this, see the bow? You're storing energy again, but not by moving an object above the ground. So it's a different kind of potential energy. That's it.